All right, let me just scroll to the beginning. So what we're doing over here is we're trying to derive this formula over here. Whoops, let me get my eraser out. Erase this business over here. So we're trying to draw this formula over here. And let me just read it to you. It says a circle is inscribed in a triangle if the triangle's three sides are all tangents to a circle. All right, that's an inscribed circle, by the way. In this situation, a circle is called an inscribed circle, and a center is called the inner center of the or in center. Let R be the center. Let R be the center of the radius. You know what? I made a mistake over. I have to readjust the. Let R be the radius. All right, I have to. R is the radius of the circle. It's the inscribed circle. To the triangle sides are A, B, and C. We need to show this. So again, I need to reword this over here. Reword. And again, what do we need to rewrite? R is not the center. R is the radius of the circle that's inscribed in that triangle. Now I'm going to derive this formula over here. I want to point out before you do that, though, I think it's a good idea to look at this video over here. And the reason for that, it's really a simple case of this. I'm not going to say it's going to give you a generalized case, but it's a really simple case, 3, 4, 5, and you're able to figure out the radius of that, all right? So what I want to do now is go to the whiteboard. And I certainly, in the back of my mind, I understand what they said. My pictures are never really quite good, by the way. But I'm going to make some attempt to draw a circle. And then I'm going to put a tangent line here. That's supposed to be tangent, by the way. I'm going to put another tangent line over here. All right, that's tangent. And I'll put a tangent line over here. Try to do the best job I possibly can. And what I'm going to claim over here is that this is an inscribed circle, right, to this given triangle over here. And I'm going to say, looking at it, same thing I did in the prior video. I'm going to put little lines over here. And these lines are going to be the radius of the circle. And it's tangent. And all these things are at right angle. All right, I know that much. So what do they tell me? They tell me the three sides of it. And they tell me this inscribed circle has a radius r. So I'm just going to arbitrarily say this is A, this is B, and this is C. And all these radiuses are just simply r. All right? So when I look at their formula, I look at it and I think to myself as, again, we just wanted a right triangle one. I'm not going to say this is, it may look like a right triangle, but I'm going to say it's not a right triangle. All right? But I'm going to say, I'm looking at what they want me to derive. And what they want to derive is they want me to show that 4 times A plus B plus C times R squared is equal to B plus C minus A and A plus B minus C, and then they got A plus C minus B. Well, I got suspicions that looking at this thing over here, it sure does look like it might be related to Heron's formula. Again, when I say this over here, it's important you saw the 3, 4, 5, and I just did, the area that was really is right triangle. It's 1/2 base times height, but it's not going to work over here, all right? So what I'm going to do is I'm going to use Heron's formula. And Heron's formula is kind of interesting, and it's derivable, and it's also in the notes, by the way. S is called the semi-perimeter. It's A plus B plus C over 2. And then the area of the big triangle, by the way, is going to be pretty simple to write down, by the way. All right? It's going to be S, and then it's going to be S minus A, S minus B, and then S minus C. So what I want to do is I want to, write that down now. And someone says, well, what are you writing down? I'm writing down the area of the big triangle. So the big triangle I'm talking about is this triangle over here. This is the big one. Just like I did before for the right triangle, by the way. So let me write that down. So that area of the triangle, I'll call it AT, by the way, is going to be, I'm going to use Heron's formula. It's easy. And what do you get there? You get the root. It's going to be kind of complicated to write down, but I can write this down. A plus B plus C over 2 times, well, it's going to be A plus B plus C over 2 minus A. We'll simplify this in a moment. A plus B plus C over 2 minus B. A plus B plus C over 2 minus C. All right? I'm going to still massage that as much as I possibly can. And what I'm going to do over here is just, try to get the common denominator and see what I can handle in this one over here. And you get this over here. I'm going to put this one down. You get A plus B plus C, 2. Here comes my common denominator now. You're going to get, let's see, you're going to get B plus C, that's over 2. Then you get A minus 2A, which is simply minus 1A. What do you get next? Well, let's see, you're going to get A plus C, this is all over 2. You can get B minus 2B, which is minus B. Nice pattern to it. What do you go here? 2. And then you're going to get A plus B. Now it's going to be plus C minus 2C, which is minus C. All right, I'm going to keep moving forward on this one over here. And I see the bottom is 2 times 2 is 4, times 2 is 8, times 2 is 16. And the square root of 16 is 4, so I get 1/4. Then what do I get? I get this. I get A plus B plus C. You know, maybe I should put this in parentheses. And then B plus C minus A plus C minus B, A plus B minus C. All right, did okay there. That's the big triangle, by the way. Now what I'm going to do, I'm going to do the 3 smaller subtriangles, all right? And the way I'm going to do that is like what I did before, you know, kind of divide this up into 3 separate triangles. And again, it's a good idea you watch the video on the right triangle. And I'm going to say over here, it doesn't look too bad. Like, for example, this one over here, the area of this one over here is fairly simple, right? And what's it going to be? The area of that thing, I'm going to use that 1/2 base times height. So the area of this guy over here is 1/2. What's its base? Its base is A. And what's its height? Its height is R, all right? Let me do the next triangle. And I'll do this one over here now. Let me get blue. I'll do this one over here now. And what's that going to be? Let's write that down. It's going to be 1/2 times the base, which is B in this case, times the height of it, which is still R. Let's go to the next one. I'm going to use yellow now. And I'm going to use triangle over here. And really kind of same thing. It's going to be 1/2. What's the base of that? C. And the height of that is R again. All right? And if I add all these 3 things together over here, I'm going to get the total area. So let's write that down. All right? I'm going to go back over here. So this here is going to be equal to, let's make sure I'm doing that right over here. I'm going to factor out a 1/2 R. Then go back to black. Yeah, I want to put on I'm looking this over here. So I'm factoring out the 1/2 R from each term. And what do you get? A, B, C. That's not so bad. Write this down. A plus B plus C. I want to point out these 2 are equal. All right? Now again, you want to back and look at the formula, but I know the formula doesn't have a root in it. And it doesn't have any, I don't think it has any fractions in it either. So I'm going to multiply both sides by 4. And what do you get? You would get 2R, A plus B plus C. Again, I'm multiplying both sides by 4. Then you're going to get equal this thing over here, which is A plus B plus C, B plus C minus A plus C minus B, A plus B minus C. All right, the next thing I do is going to square both sides. And what do you get? You get 4R squared, A plus B plus C squared is equal to A plus B plus C, B plus C minus A plus C minus B, A plus B minus C. Now I'm certainly getting close to what I want, but I'm not there yet. All right. Now, so what are you talking about? I'm looking at what I'm supposed to be getting. I'm supposed to be getting, 4R squared. I do see that, but I got a square there. So what I'm going to do is divide both sides by this thing. I don't want that. And what do I get now? I get 4. I get A plus B plus C. I get R squared. And what do you get on the right side? You get B plus C minus A plus C minus B, A plus B minus C. All right? Now, the thing is, you can look back at your notes, by the way, and what they want you to derive. Did we derive what they said? Well, I got this thing. Did I get the other side? Let's see, B plus C minus A. I do see that. A plus C minus B, I do see that, and A plus B minus C. I'm seeing it all. So we're supposed to derive QED, all right? Wasn't as bad as it looked. However, if you didn't know what to do in that one, it's gonna be impossible to do, in my opinion. But anyway, we're done. Thank you.